Today we're going to start Chapter 5. So we're doing Lesson 5.1. Chapter 5 is all about systems of equations. So in 5.1, we're going to learn how to solve these systems by graphing. And then in the next few lessons, we're going to learn different methods for solving systems like substitution, elimination. So this lesson right here is all about graphing. So make sure you've got your graph paper. Okay, so to start, there's a couple different ways that your homework is going to word questions in solving these systems. So let me clarify really quick. These two equations right here work together as a system. So what we're solving is one xy coordinate that makes both of these true. So that's what we're looking for. We're looking for one coordinate that you can plug in for the x here and the y here, and it makes both of these true. Okay, so all we're going to do right here in the beginning is we're going to determine if the given value is a solution to the system. So basically, does what's in red, does this xy coordinate make both of these equal signs, these equations, true? So to solve that, you're going to have to plug the xy coordinate into both of the equations and see what happens. So if I plug the 2, 1, which remember, this is x, comma, y, okay? So if we plug this into the first equation, it would be 2 times the x, which is 2, plus 3 times the y, which is 1, and does that equal 12? That's what we're trying to decide. This would be 4 plus 3. Oops, sorry. I wrote the actual answer. 4 plus 3 is 7. So does 4 plus 3 equal 12? No, it does not. It does not equal 12. So it is automatically not a solution because it does not satisfy one of the equations. Okay, but you could try it for the other one and just see what happens when you plug it into the other. So if we do this equation here, you've got 3 times the x, which is the 2, minus y, which is the 1, and does that equal 7? 3 times 2 is 6, minus 1. Does 6 minus 1 equal 7? No, it does not. It equals 5. So because it is not true, neither of these equations is true. In fact, both of them are false. That means that it is not a solution. So your answer to this problem, determine if it is a solution, would be not a solution. Okay, let's do another one. And in the next one that we do, we're going to keep these same equations and we're going to use them in the next problem. Okay, so on the next example, we're going to use the xy coordinate 3/2, comma 3. So this would be x, comma y. All right, so we need to just plug it into our equations, which I wrote them over here to the side. We need to plug them into our equations and see if it makes both of them true. If it doesn't make both of them true, then it can't be a solution. So let's try it out. The first equation says 2 times the x is 3/2, plus 3 times the y, which is 3. Does that equal 12? Okay, so right here, this would be 2 times 3 is 6, divided by 2 is 3. And 3 times 3 is 9. Does that equal 12? Yes. 9 plus 3 is 12, so 12 equals 12. Okay, so it checks with one of them, but remember, you have to check it with the other one, because if it doesn't satisfy both, then it's not a solution. So you can't stop here. You have to keep going. So let's plug it into the other equation. It says 3 times the x, which is 3/2, minus the y, which is 3. Does that equal 7? Okay, so here, this would be 3 times 3 is 9, divided by 2 would be like 4.5, right? But I can leave it as 9/2. Or if you want to think about it better, because you're just testing it, you can put 4.5 minus 3 equals 7. Does 4.5 minus 3 equal 7? No, it does not. So, it is not a solution to the second one, which means that overall, it is not a solution. It has to satisfy both. Okay, we got one more. On the last one, we're going to use the point 3, 2. Remember, x, y. Okay, it's really important. If we get that mixed up, then you're not going to do these problems correctly. So you have to remember it's x, y. All right, so let's plug it into the first equation. 2 times the x, which is 3, plus 3 times the y, which is 2. Does that equal 12? 2 times 3 is 6. 3 times 2 is 6. Does 6 plus 6 equal 12? Yes, 12 equals 12. So we have a check there, but we have to go try the other one. So 3 times the x, which is 3, minus the y, which is 2. Does that equal 7? 3 times 3 is 9, minus 2. What is 9 minus 2? It is 7. So it works. Since it works in both equations, this means it is a solution. Okay, so it has to work in both. That's the only way. It can't just work in one. All right, so before we start doing this with actual graphing, there's a few things we need to talk about. And you can always pause this video if you need to copy this down, but these are like the biggest takeaway notes from this lesson. Okay, so we've got 3 types of solutions, and you're going to need to know all 3. So the first type is intersecting lines. Okay, so if you see the picture down at the bottom in red, it would be 2 lines that are graphed and they cross at 1 point. 1 point, right? Because they're straight lines. So they could only cross at 1 point. If they cross at 1 point, then there is one solution. And the solution is the point where they cross. Okay? And then this would be called a consistent system. A consistent system because it has at least one solution. Okay, so then the next type of solution you can have is parallel lines. So obviously y'all know parallel lines never cross. So in the picture at the bottom of the orange, it's the 2 parallel lines that are graphed. They never cross. Well, if they never cross, then there's no solution. So no solution, and that means that they would be an inconsistent system. Inconsistent, because there is no solution. Okay, and then the last one is called coincident lines. Coincident lines. Coincident just means the same. Okay, so what would happen is you would graph 2 equations and they would turn into the same line. And you'll see examples of this. But graph 2 equations, they end up being the same line. So down at the bottom in blue, I only have 1 line drawn because I had 2 equations, but they were the same line. The same line. So if that happens, you have to think about it. How many times do those lines cross each other if they're the same line? They cross each other in 1,000,000 points, right? More than that. It goes on forever and ever and ever. They cross forever. So because of that, there is infinite solutions. Infinite solutions. And again, it would be consistent because there's a solution. Okay, so if you need to pause this to finish writing these down, that is perfectly fine. I'm going to go ahead and move on to the next slide, so you can always resume the video whenever you're ready. Let's do one of these as an example, okay? So solve each system graphically. That means that we have to graph them. All right, so we're going to pull in what we talked about in the last lesson. The last chapter that we just took a test on. We're going to pull in some of those pieces, But these are just equal signs. Okay, so there's no graphing. There's no shading. There's no dotted lines versus solid lines, nothing like that. Okay, they're equal signs. But what we're going to use that we used in the last chapter is the intercepts. So if you can remember, what form is this written in? This is standard form, right? So you can do one of two things. You can use your intercepts, or you can rearrange the equation and make it say y equals, and then go from there. Both ways we should get the same answer. Okay, so I'm going to use the intercepts, and I'm going to show it that way. So if I'm finding the x-intercept, then we need y to be 0. And again, we have two equations here. So you're going to have two different x-intercepts. We should graph two different lines. Okay? Two equations, two different lines. So if I plug the y equals 0 into the top one, that would be x plus 0 equals 9. Well, that just means that x equals 9. Right? So there's one of them. If I plug it into the other equation, it would be x minus 0 equals 5. Well, that just means that x equals 5. So now I have my two x-intercepts. Let's go find the y-intercepts that go with these, and then I can graph these lines. Okay? So y-intercept, if I'm finding y-intercept, then we want x to be 0. So in the first equation, it would be 0 plus y equals 9. Well, that just means that y equals 9, okay? And look, these go together. These 2 points, because they came from the same equation, they go together on the graph, okay? So don't get those confused. All right, the second equation would be x is 0 this time. 0 minus y equals 5. Okay, we have to slow down here for just a second, because this says negative y equals 5. Negative y equals 5. Well, that y is not by itself. That negative sign has to be put over on the other side. So when you divide by a negative 1, you get that y equals a negative 5. Okay, so now I've got two sets of points that I can go graph for each equation. So the top equation, I have x equals 9 and a y equals 9. So on the x-axis, we're going to go put a dot at 9. On the y-axis, we're going to go put a dot at 9. Okay, so x equals 9. That's 9. And on the y-axis, I almost did not have enough lines here. And that's 9. Okay, so then the other point, this line, has x equals 5 and y equals negative 5. All right, well, let me go ahead and connect these really quick, because I don't want to get my lines confused. So you can use your straight edge, your piece of paper. I'm going to try to make this as straight as I can. And make sure it has arrows, okay, because it is a line. And I will tell you right now, you're going to want to use a straight edge or a piece of paper to make that straight, because you're looking for the one point where they cross. So if you don't have your lines straight, then you're probably not going to get that point right. Okay, so just something to keep in mind. All right, so the second line has x equals 5 and y equals negative 5. So x equals 5 is here, that's a 5. And y equals negative 5. So now, see, just like this, you're going to want these lines to be super straight. Super straight, because mine's probably not going to cross in the exact right spot. Okay, so if your lines are straight, you should have one point, let me use a different color, one point where these cross each other. That one point is your solution. Does anybody remember what type of solution this is? This is called intersecting lines. Okay, intersecting lines have one solution, And your picture should be better than mine. So you need to go figure out what is the XY coordinate that makes up that point right there. Okay, so this is 7 on the x-axis, and it would be 2 on the y-axis. So your solution point is 7, 2. And that's your answer. Okay, so you graph the two lines, you figure out where they cross, that's your solution. Okay, also, you could go back in and check your work, like we did in the first few examples, and you could plug the point 7, 2 back into your original equations and make sure that it makes both of them true. Okay, let's do another one. Oops, sorry. All right, this time we have x plus 2y equals 6 and x minus 2y equals 0. All right, so let me see if you remember from the last chapter that we did. When it equals 0, that's just like if it was 0 on that side of an inequality sign, okay? The 0 by itself means that your x and y intercepts are just going to give you the origin, okay? Your intercepts are just going to give you the origin. So the origin is not going to be enough to graph that line. You have to also have another point. There's two things you can do. You can say, all right, well, this time I will let x equal 1. And let's plug 1 into here and figure out what my y would be. Okay, so if I were to solve this, if I subtract the 1 from both sides, you get negative 2y equals negative 1. And then you divide by a negative 2, so y would be positive 1/2. Okay, so one way you could do this when you get the intercept as the origin is that you can pick another point for x, plug it in, and get your y point. And now I've got 2 points that I can graph. The other thing that you could do is you could rearrange this equation to say y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so basically you could just move things around and you could rearrange it if you wanted to do it that way. Okay, all right, but because I've got my 2 points for the second line, I'm going to leave it just like that. And I'm going to go work on the first line. My first equation up here. I need to use my x and y intercepts. It's in standard form. There's no equal to 0, so I'm going to use my intercepts. So if I'm finding the x-intercept, we would say y equals 0. So it'd be x plus 2 times 0 equals 6. That means that x equals 6. Okay? If I'm finding the y-intercept, then you want your x to be 0. This would be 0 plus 2y equals 6. Divide by the 2, you get y equals 3. Okay, so on the second line, I have the intercept and a different point. And on the first line, I have 2 intercepts. Okay, so now I'm going to go graph these. I'm going to do the orange part first. So x-intercept at 6, y-intercept at 3. Go over here to your line. Here's 6, y-intercept 3. And then I can draw a line through the points. Again, you're going to want this to be straight so that you can figure out where they cross to the best of our ability. Okay, so there's one. The other line I have in red, I have the origin at 0, 0, and I have the point 1, 1.5. So the origin is 0, 0, and then 1.5. Didn't make those points very far apart, did I? I'm going to help myself out here really quick, and I'm going to give myself another point. So I plug in a 5 for x. Subtract the 5. Divide by a negative 2. And 5 halves is the same thing as like 2.5. So now I've got the point 5, 2.5. I only did this because in my graph, my points are so close together. I want to make sure that my line is straight. So this is just for me personally. I'm going to put another point on here. So at 5, we're going to go up 2.5. There we go. So now I at least have one other point on there that I can connect. It's hard to make these lines straight on the iPad. Okay, so you should have one crossing point. That crossing point is the solution because these are intersecting lines. And so now we just need to figure out what is the XY coordinate that goes with that point. Okay? Well, on the x-axis, we're at 3. So 3 is my x. And on the y-axis, we're really in between the 1 and the 2. We're in between the 1 and the 2. So it's like 1.5. 1.5. 1.5. So that's the solution to these lines. Okay, so if they're intersecting lines, they have one solution. The solution is where they intersect. If they're parallel lines, they have no solutions. And if they're the same line, if you rearrange your equations or anything like that, or find your intercepts and they're exactly the same for both equations, and you get the same line, then it's infinite solutions. Okay, so on your homework, there's really not very many of these. The first 4 are just like what we did in the beginning, where you're deciding if the given point is a solution to both equations. And then you have 6 graphing. And that is it. So I hope you guys have a happy Friday, and I will see y'all on Monday.